If you're watching this video, you've probably been confused by all of the conflicting deadlift technique tips out there. Start your hips lower. No, start your hips higher. Straighten your back completely. No, rounding the back a bit is fine. Listen, I've been there. My goal in making this video is to give you a framework that you can use to cut through all the noise and find your own unique best deadlift form. How is it even possible to find such a framework? We all live in the same universe with the same laws of physics. So that means that there are things that apply to everybody. For instance, compare bending your knees at the start to drive your legs into the ground versus locking out your knees and being unable to drive your legs into the ground. Which do you think is stronger? Probably the one that allows you to drive into the ground better. And is this going to apply to everybody? Or are there outliers for whom they will be stronger ultimately with a straight leg? No, this applies to everybody, okay? This is self-evident. You don't need a million studies to confirm this. You don't need a physics degree either to understand that you're going to be stronger by pushing into the ground with your whole leg versus by depriving yourself of that. So if that makes sense to you, if you understand through that example that there are things that are constant for everybody, then from there, it's just a matter of, okay, what are all of the other constants? And how are we going to find those other constants? Well, first we have to define what a deadlift is and what it isn't. A deadlift is a wedge motion. Think of it like a nutcracker, okay? A nutcracker, it's got two handles that are squeezing in towards the nut. And so as it squeezes in enough, what happens to the nut? The nut splits apart into two. One end drives this way, and then the other end drives this way. Does that make sense? I'll say it one more time. A nutcracker has two handles. It squeezes inward, it wedges in this way, and then the nut splits apart in perpendicular directions. And that's a deadlift. You may be wondering, wait, how is that a deadlift? Okay, your hips, they go back and then they drive forward. Your arms, they pull the weight in towards your body, right? Those are the two handles of the nutcracker. Your hips drive forward, your arms drive back, and in turn, your legs drive down, that's one half of the nut, and then your torso rises up, and that's the other half of the nut. Does that make sense? I'll say it one more time. The nutcracker squeezes in this way, the bottom half of the nut goes this way, the top half of the nut goes this way. In a deadlift, your hips and your arms are the handles of the nutcracker. They move together like this, and your feet drive into the ground and your torso rises. And because the weight is attached to your torso, that's how the weight is lifted. So if you can understand that, then it's just a matter of configuring your body to execute on this wedge concept. I just outlined the 4 pillars of that wedge. You got your hips, you got to be able to load them back so that you can spring them forward. You've got to have the lat engagement to be able to pull your arms towards you this way, right? You've got to know how to drive your legs into the ground solidly. That's the bottom half of the nut. And you've got to have a rigid enough torso for your torso to rise from those 3 other actions happening. Okay, if you can understand that, then you can find the exact cues that will work for you, because you'll just focus on what actually matters. What are the constants of all proper deadlifts? So this is the first part of this video. We're going to go into the 4 components of the wedge that we just talked about in the next video. Stay tuned.